and this is our Q. And this is again the secant line. And this is now the tangent line. So this is the secant line. Secant PQ. Secant PQ. And this is tangent at P. Okay. Now, the question here is find the equation of the tangent line at P. And P has coordinates, of course, as we already told me, x f of x. Okay, do we have the equation of a line? Because it's a line, right? A line passing through a point. Can anyone give us the form of the equation of a line passing through a point? Anyone?
Y equals mx plus b. No.
I don't have the y-intercept. It would have been y equals mx plus b if I have the y-intercept 0, comma b. I don't.
Is it y minus y1 equals m, and then in parentheses x minus x1?
That's it. Thank you very much. Who was that, Caitlin? No?
Christine.
Yes?
It was Christine.
Christine, thank you. Perfect. That's what it means. So we have a point. This is the point. x1, y1. And the slope. And I can determine the equation. But you can say, wait a minute. You have the point. Yes, I do. So the point is x comma f of x. This is the f of x. And this is the x, right, from P. But what about the slope? How do you determine the slope of this line? You only have one point. I can determine the slope of a secant line because I have 2 points. y2 minus y1 over x2 minus x1, which we just did. But how do I determine the slope of this line? I only have 1 point. How do I determine the slope? Okay. I would like us to open the book and choose a problem. So in 2.1, if my computer cooperates, okay, it does. Okay. Feel free to choose. I don't have any preferences. Let's start with this one. Number 4. Okay, so problem 4 in section 2.1. I will stop sharing in a second. I just want to copy. So we have P 0.5 comma 0, and we have y equals cosine pi x. If Q is the point, of course, Q is the point x comma cosine pi x. Find the slope. Okay, so they're giving us some points. So they say 0, 0.4, 0.49, 0.499. Then on the other side, 0.501, 0.51, 0.6, and 1. And I don't need the rest. Use the slope. Yes, I know what they want. That's it. Perfect. Okay, so I am not graphing the function. I'm just going to show this is the graph of a function. This is the point P with 0.5 comma 0. And this is the point Q, which has coordinates x cosine pi x. And what I want to determine is the slope of the tangent line at this point. We are going to start, like in my drawing here, we're going to start with PQ. Then we are going to bring, Q can be on either side. Q could be here on the graph, or Q could be here, it doesn't matter. And then I'm going to bring Q closer and closer, closer and closer to P. So in other words, this secant line will become, if Q is here, will become this secant line. If Q is here, it will become this secant line. If Q is here, it will become this secant line. And you understand what's happening. As I bring Q closer and closer to P, the slope of the secant line gets closer and closer to the slope of the
Tangent line?
closer and closer to the slope of
The tangent line?
exactly. Great job. Exactly. So let's determine the slope PQ. First, the slope of the secant line PQ. How do I write it? Can anyone give us the slope of the secant line PQ? Disregard what we are trying to do. We are going to get there together. But just tell me, what is the slope of the secant line PQ? How do I write it?
Would it be cosine pi x minus 0.5, no, minus 0
Awesome. Over?
over x minus 0.5?
Great job. Thank you.
Can you walk me through that, how you got that?
y2 minus y1 over x2 minus x1.
A little slower.
y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1. y2 minus y1 over x2 minus x1.
Okay, thank you.
They are all the same. We are talking about the slope of the secant line. y2 minus y1 over x2 minus x1. That's why we wrote them here. y2 minus y1 over x2 minus x1. Is this okay?
Yes, that makes sense. Thank you.
Everyone? Everyone with me? Okay, so I don't need a 0 here. So I'm just going to continue simplifying it, and I think I'm on page 7. Yes, I'm on page 7. So the slope of the secant line PQ is cosine pi x divided by x minus 0.5. Now, when Q is here, see, we have different values of x. This x can be 0, can be 0.4, can be 4.9, can be 0.499, can be this, can be this, can be this. And of course, this will change. If x is this, I will get a different value. If x is this, I'll get a different value, or so on and so forth. So now I want to calculate this for all those x values. I want to calculate the slope of the secant line when Q is at 0, when Q is at 0.4, when Q is at this, and so on and so forth. So I'm going to create a table. So x and the slope of the secant line, PQ. I have to watch the time here. Okay, it's 10 minutes, that's good. So I will put all these numbers in the correct order as I have them here, not the way they are throwing them at us, intentionally to mislead us. They have to be in the correct ascending order. And if you notice here, there is 0.5 that is not in either left or right. Why? Can I put in 0.5 here?
No, because then the denominator would be 0.
And the entire thing undefined. Very good. So I'm going to enter 0. And then 0.4. And then 0.49. Then 0.499. I'm going to leave it blank here for 0.5, although 0.5 is not in the table. Of course, you know I ran out of room. I always do. Okay, so it's continued here. You do not have, if you have room, please put all of them together in the same row. I never do. So I have 0.5, 0.51, and the last two. Okay. We're going to grab our calculators. I'm sharing my screen. I have my calculator up here. Sorry guys, I have to move you. In y equals, erase everything. We are going to enter, make sure, go back to mode. Make sure that your mode is in radian mode. Click on mode, make sure that you have radian. And then in y equals, we put in a numerator, which is only one function, so I don't have to put it in parentheses. Pi x, here's pi, right here, the caret, and x. Close the parenthesis for the inside the cosine, and divide now by, now we need parentheses, x minus 0.5. This is a function that is basically the slope of the secant line. We just put in the calculator. Make sure, go back to second and table set. Make sure that you have the independent variable in the ask mode, so you can put in the answers, the x values that you want. And then go to second and table. And I'm going to enter one by one what I have for x. I have 0. I have 0.4. I have 0.49. I have 0.499. Again, what do you think is going to happen when if I decide to enter 0.5 again? I will get the word error. It better be. Okay. And then 501. Oops, I didn't mean that. And then 0.51. And then 0.6. And then 1. And now I'm going to copy them, but make sure you go to the right to see all the digits if you need to. Look at what happens here. The rest of the digits are hidden. So let's use 4 decimals. So for the first one, I will copy -2. That's not a big deal. For the next one, I copy -3.09. For the next one, -3.1411. 4 digits. Scroll down. -3.1416. -3.1416. -3.1411. negative 3.0902. And the last one, negative 2. Now you could say, yes, I see that Q gets closer and closer to, the x of Q gets closer and closer to 0.5 from either side, but I'm not very happy with 0.49999. I want even closer, or with 0.501. I want even closer. Okay, I agree. So let's put 0.5000. Where it's okay, I'm on the y values, that's why, sorry. Okay, so 0.4999999, or I want negative, not negative, I meant to write 0.5, 0.50000001 from the other side. So below 0.5 with 0.49999, and tiny bit after 0.5 with 0.500001, and see what I get. Okay. So with 0.4999, again I'm on the y, we got negative 3.14. And with 0.5000, again, 0.5000000001, it considers it 0.5. It's so close to 0.5 that it considers it for 0.5. Okay, I'm going to stop sharing. Good. So as Q gets closer and closer to P from either side, with values of x smaller than 0.5, and then with values of x higher than 0.5, what is your conclusion here?
That would be negative 3.1.
So that's a acceptable approximation, or negative 3.14, or negative 3.1416.
Wait, so I have a question.
Sure.
As this approaches 0.5, would negative 3.14 be the limit?
Yes.
Okay, I understand. I'm on the same page.
Yes. That's what it would be. So we will conclude what? Then the slope of the tangent at P is negative 3.14. Any questions so far? Okay, so you will see a little bit later when we will talk about these functions again. So our function coming back here, I just want to test something. So you will see very, very soon in this class how we will find the derivative of this function. So the derivative of this function, y prime, is going to be negative sine pi x times pi. And because I want to check our calculations. I'm just doing a calculation on the side just to make sure. So when I plug in this y prime 0.5, sine pi over 2 will be 1, and this will be pi. So this will be negative 3.14. So this is correct. So later on, I'll show you what I just did just to check my answer. So basically, the correct answer is negative pi.
I have a question about that.
Yes.
Instead of going through the whole process of doing the table and everything, could you just do the inverse from the start?
If you just do what?
Could you just do the inverse of
You mean the derivative?
the derivative, yeah.
You cannot, not in this chapter, not in this test. For tests
Oh.
from chapter 2, you cannot use. I used it because I just wanted to double check that our calculations are correct. But you cannot do this in chapter 2. If you're asked to do the table and estimate the, you can check with the derivative. But if you're asked to create a table, then you have to use the table.
Okay, I understand.
But indeed, it's true. I calculated this on the side just to make sure. You chose the problem, so I just wanted to double check. Perfect. So now we can determine the slope, the equation of the tangent line. So we have y minus our p was 0.5, so y minus y1, which is 0, equals the slope negative pi x minus 0.5, y minus y1. So x minus, I'm going to write it as negative 1/2. This is not needed. I will distribute negative pi. So y equals negative pi x plus pi over 2. This is the equation of the tangent line. Line at P. So now you learned how to determine the equation of a line and how basically determine the slope of the tangent line having only one point. We only had this point, but we used values of x or point Q. We used point Q getting closer and closer to P from either side in order to estimate the slope of the tangent line. And once we had the estimate for the slope of the tangent line, we were able to determine the equation of the tangent line. Any questions?